Okay, question 4. Express 4x squared minus 12x plus 11 in a complete square form. This is, this is a standard question. You can assume that there will be one of these on the AS papers somewhere. There was an almost identical question on the second year maths papers. This will come up next year as well. This is something that you will have to do. Okay, we need to force there to be a 1 in front of the x squared before we do our completing the square. So this is 4 lots of x squared minus 3x. That's an important first step to get it to be a single x squared. Inside that bracket, there are a number of ways that people do this. This is what I do. Inside the bracket, we're going to have to put in a half of that minus 3 when you square it. So half of 3 is 3 over 2. When you square it, it's 9 over 4. So we've added 9 over 4 inside the bracket. That means we've added it 4 times, because there's a 4 multiplying that bracket. So I need to take away 4 times 9 over 4, which is 9. And then I've still got the plus 11 on the outside. My bracket there is x minus 3 over 2 when you square it. And outside the bracket, I have a plus 2 going on. And that's it. So it was 3 marks, and it was 1 mark for each of the A, B, and C in that thing. Part 2. State the number of real roots of the equation. Okay, that's the same equation we've just completed the square from. Interestingly, the second year paper did the same thing, but put a hence in there. So they wanted you to use what you've done. You could get away with using the discriminant if you wanted to, or just observe the fact that if we were going to put this equal to 0, we would find ourselves square rooting minus 2. And if you square root minus 2, you don't get any real answers. So there are no real roots. That's all that they wanted. It was 1 mark, and it was for stating it. It wasn't for explaining why. It wasn't for showing that. It wasn't detailed reasoning. They just wanted you to say there were no real roots. So make sure you just answer the question. Don't get sidetracked into finding what the roots might be. Don't use your calculator to find complex roots if you're a further math student. Part 3, explain fully how the value of r is related to the number of real roots in the equation, where p, q, and r are real constants. So this was slightly, it's the same format, but it's a slightly different question that we're now asking, isn't it? How is the value of r related to the number of real roots? Okay. Well, if we think, there are a number of ways of approaching this question. If we think about what's happened here, we've got an x squared graph that is translated side to side by the plus q. It's then stretched by the value of p. Well, that doesn't really change much. It doesn't move it up and down. It just moves it side to side and stretch it. So it's still, at that point, it's still touching the x-axis. And then it's moved up or down by whatever the value of r is. If you think about the graph then, if r equals 0, we've got that case where it's touching it at one point. If r is positive, it would move it up. If r is negative, it would move it down. If r is 0, it would give us that case there. So I think that means if r is greater than 0, we get no real roots. If r is equal to 0, we get repeated roots. 1 real root, or a repeated root. If r is less than 0, then we're going to get 2 real roots. And that's all that they wanted. Some kind of explanation along those lines. Okay, you can think about it a different way. You can think, if you were solving this equation, you would subtract r from both sides. So you would end up with an equation that said p times x plus q squared is minus r. You would then be wanting to divide by p and square root it. Now, if you're square rooting a negative amount, if r is positive, that would be negative on the right-hand side, and you can't square root a negative number and get a real answer, so that would be no real roots, and so it follows the same logic follows at that point. Or you could multiply it all out and do the discriminant, but you're getting tied in knots, I think, by doing that. That's the straightforward way. Think about it as a transformation. And that's maths.